Good evening, everyone. Welcome to week 5 of the Sustainable Small Farming and Ranching Whole Farm Planning class. Tonight, the topics we're going to cover are crop production, soils, and pest management. Next slide. Again, our webinar tips. To close all the other programs running on your computer, check your sound. If you're having any problems with clarity or speed, please go ahead and switch to the phone and mute your computer when you're using the phone. And you can type in questions for speakers into the question box. We are going to try to have a short question and answer period this evening. We do have a lot of material to cover, so if we don't get to all of your questions, then we will pass them on to our presenters and ask them to answer the questions, and we'll post them in the discussion forum on the class website. Next slide. So today's speakers are Kathy Perillo. Kathy's in Crop and Soil Sciences at Washington State University on the Pullman campus. And though she doesn't often call herself a small farmer, she also raises a small flock of sheep and a lot of different kind of poultry on their farm in Viola. And she's going to be talking about soils tonight. And Jessica McAleese with Ladybird Farms, who you've heard from throughout the course, is going to be talking about crop production. Cinda and myself, Colette D. Phelps, are in the background answering questions and facilitating the webinar. And Melissa Lines is also here to answer questions. Next slide. So we're going to go ahead and hand the presentation off to Kathy.
Good evening or late afternoon, everybody. Hopefully you are excited to learn about soils. I teach this class, Introductory Soils, as a class on the Pullman campus, and the students often are like, yeah, we're really excited about soils. And I convince them by the end that it really is exciting, and I think some of them believe it, or at least they tell me that they do. I'm going to go ahead and, whoops, I think we lost our slide control. There we go. Let's see, so we're going to talk about soil, especially with the characteristics that are important for plant growth. Soil plays other functions as well, and some of those we'll touch on a little bit, like environmental quality and filtering water supplies and things like that. So here's my starting definition of soil. This is one I ran into years ago. Soil is a very slow motion whirlpool or short segment of a river of mineral and organic matter. It is a turnstile through which passes an endless procession of atoms. And that's just how I start my intro soils class, and the students get really big eyes when I say that, give them that definition at the beginning. And I give them some other definitions too, like the functions. But I think if you remember one thing from today's session, I think it's to think of soil as not inert material, but the fact that there's all sorts of biological chemical reactions going on and physical processes, and it's actually quite complicated. Here's a list of what you all might be thinking makes a good soil, and I would agree. It drains well, doesn't pond water, it doesn't crust after you plant it, seal over the surface. Rain falls, gets soaked into the soil, moisture gets stored when it's dry. It's not really cloddy and doesn't have hard pans. It's easy to work. In other words, it resists erosion, it holds onto its nutrients, it produces healthy and high quality crops or food for livestock, if we're looking at it from that perspective. Okay, so those are some of the characteristics. We could probably come up with a few more. So getting down to the real basics, like what in the world is soil actually made of, and we can really put it down to about four general things: minerals, air, water, and organic matter. And the first and last we think of as the solids in the soil, and the air and water are the pore space. If we look at it in a pie chart of a typical soil, or a soil, kind of an ideal soil maybe, and this varies tremendously, but we'd like it to be roughly half pore space, of which half of it would be water-filled pores and half would be air-filled pores. So we'd have the air for our plant roots and our organisms in the soil, but they'd still have water that they need. The mineral fraction, you could see it's mostly minerals and organic matter, whether that's live tissue, plant roots, living biomass, which is a very small fraction, that plus all of the dead and decomposed material. 5% was actually a fairly good organic matter level. A lot of soils have less. Of course, there's some soils that are dominated by organic material, and we're not really talking about those, but that would be like a peat soil, and that has some different principles coming into play. So it's important to, if you have that kind of soil, maybe send that in terms of a question and we can try and address a few things. But in the meantime, we're going to really focus on these mineral soils that have organic matter in them. Okay, if we look at it, that organic fraction a little bit more closely, as I said, the living biomass is a small proportion, maybe about 5%, and the humified or the highly decomposed, non-living, no longer recognizable tissue is, the humus fraction is maybe 60 to 80% of the organic matter in the soil. And of course, there's other like plant residues like leaves that you can still sort of recognize as leaves that are in between, and that's another small percentage. Even though it's a very small percentage of the amount in the soil, only about 5%, like we said on the last slide, it's incredibly important for both chemical and biological and really physical reasons. Okay. You could think of it, maybe a concept to remember in 10 years. So, okay, another thing to remember from tonight's seminar besides my first definition. Here's kind of, when we look at two soils and people hold them up and say, oh, this is a good one, this is not so good. The soil that you're seeing on your right, in this case is from a manure amended crop rotation compared to a conventional crop rotation on the well, the person's right hand, our left, you can see that difference. And I think most of us would look at the one soil on the right there and say, wow, that's a better soil. And what we're really seeing is the influence of organic matter having a higher, more active, maybe more diverse set of organic materials in it. So, of course, it gives it that nice dark color we like to see if we're lucky enough to have those kinds of soils. But the real benefits of organic matter include having increased water and nutrient holding capacity. Something we'll get into a little bit more later on is the formation of soil in stable aggregates, not just acting as individual particles. And because of that, it improves the water infiltration and also supports a diversity of soil organisms. And we think of diversity usually as helping to maintain the stability of the system. Okay, so that was a little brief overview of the organic fraction. Let's look at the mineral fraction here. And this is roughly to scale, the sizes of the sand, silt, and clay, and the different diameters of the actual particles are defined. And I should warn you that engineers have slightly different boundaries between sand and silt and between silt and clay than agricultural. I guess it's the USDA definition, and that's usually what's used in most agricultural applications. So for most purposes, you could say silt and everyone knows what you're talking about, but sometimes you need to know exactly what the diameters are for, usually more on the engineering side of things. If you had a handful of it and you were feeling it, if you felt sand, you'd feel the grit in there. You would not feel grit in a silt-dominated soil that didn't have sand in it. And if you did and you knew there wasn't sand in it, it's because you haven't broken apart. Maybe there's little clay and silt aggregates in there that are sand-sized. Okay, and then clay are those very, very, very small particles, less than 0.002 millimeters in diameter. And if you were working some soil in your hand, any stickiness that you felt, that would be from the clay. And silt in between feels kind of smooth. And when I was learning this, my teacher talked about it feeling like butter, almost butter smooth, not sticky smooth. Okay, and you'll see typically the mineral fraction might be about half of the soil. Well, we can take these numbers of sand, silt, and clay, like how much. You get a soil test and it tells you you have a certain percentage of sand, a certain percentage of silt, and a certain percentage of clay. And you can use the, can you guys, I hope you can see this. I think you can, the mouse on there, or else we'll talk through it. Let's say you know from your soil test that you have 20% sand. I mean, clay. Let's start with clay. 20% clay. You would come in on this clay axis here, okay? And then now we have our percent sand on this side. Let's say it was 20% clay and 50% sand. We'd come in here until we met, here's our 50% sand line, and we'd know we were in a loam texture, loam soil texture, that's what we call it. And there's always a good check because the third number should be the silt content, and that should add up to 100%. Okay, so our soil texture is our percentage of sand, silt, and clay, and we put them in these classifications of loam, clay loam, sandy clay, loamy sand, those types of things, and that's what our soil texture is. Here's kind of a simplified picture. I kind of like this one. Everybody always wants to have loam because it has equal influence of sand, silt, and clay. It sort of has the benefits of all of those different materials. And if you're outside of the loam area, you'll feel, maybe a little extra gritty, a little extra clayey, sticky, and maybe if it's particularly smooth, you would feel that over there if it was very silt rich. And here on the Palouse where we are, we have a lot of silt in our soils, and so we're kind of in this range over here in a silt loam actually. Okay, so why do we want to talk about soil texture? Well, soil texture is one of those just fundamental basic things that influences what's going on in your soil. You can change a lot of things in your soil because of management. You cannot really change your soil texture too much. Soil texture is going to have an influence on your water intake rates. It's going to have an influence on your water storage, how easy it is to till, how much air you have in there, your soil fertility, your nutrient holding capacity. All of those factors are due to soil texture. One point I should make right here is you notice organic matter did not come into the definition of soil texture. Okay, so I'm going to just go back a slide, and you have this in your handout if you're following along. Actually, let's go back 2 slides. Back to our texture triangle, as we call this. You notice we have sand, silt, and clay. We do not have organic matter in here. It's purely based on the size, classifications, and distribution of the mineral particles in there. You could have high organic matter or low organic matter, regardless of what your soil texture actually is. There's some relationships out there, but those can be changed, and they do vary naturally as well.